Hello, pre-algebra students. We're ready to start talking about circles. And first we're going to talk about their circumference. Before we can even talk about the circumference of a circle, let's make sure we know the definition of a circle, which is the very first sentence here. A circle is the set of all points in a plane that are the same distance from a given point. And that given point is called the center. Now notice I highlighted the words in a plane. Because if I said the set of points a given distance from a given point, and I did not give you the restriction of it being in a plane on a piece of paper, then we could talk about three-dimensional. And if you can think about a shape that's a given distance from a given point and think of it three-dimensionally, not contained in a plane, we might think of a basketball or any other sphere, because those points are also a given distance from a given point. They're just not contained in a plane. So for our class, we're only going to be talking about circles in a plane. Now, here on this graph, that center, see there's the definition there, the center is the given point, and that given distance, the distance from the center is called, and this should not be a new word for you all, the radius, and that's the distance from the center. Now if we put two radii together and go all the way across the circle, the distance going all the way across the circle is called the diameter. And again, that should be a review for you all as well. So the terms of a circle, the center, the radius, the diameter, we need all of those terms to be able to talk about the circumference of a circle. And the circumference of a circle is basically the distance around the circle. That's what I want you to remember. It's like perimeter of a circle, the distance around the circle. And you find the distance around a circle by using the Greek letter pi, which is approximately 3.14. Your book wants you to use 3.14, but we all know that pi equals, Yobed?
3.141592 ellipses.
This is Carson and Yobed. Eat more pie.
All right, so 3.141592 ... We don't know exactly where pi ends. So we'll always say it's an approximation, especially if we're going to stop at 3.14. So how do we find the circumference? The circumference, the formula to find circumference is right here. It's pi times the diameter, and the diameter is really just 2 radii. So you can use either equation to find the circumference of a circle. So let's do this first example together, and I'm going to leave the other 3 for you to try on your own. So circumference equals pi times diameter, and the diameter is 2 radii. So 2 times 7, because 7 kilometers is our radii. We'll put kilometers there. And 2 times 7 is 14. And pi, they want us to use 3.14. So it's going to be 3.14 times 14 kilometers. And that's going to be approximately 44 kilometers or kilometers. So that's our circumference for this circle. And that's your final answer. So you put a box or a circle around it. All right, see if you can do the other 3 that I have left there. Now remember, diameter times pi, for number 2, you already have the diameter. So you're simply going to be multiplying 9 times 3.14. For number 1, you'll have to multiply the radius times 2. Okay, try those on your own and then flip the paper over. On the back, we're going to be using circumference to solve word problems. So our first example here is talking about a garden. Arlene works at a retirement home that has a circular community garden with a circumference of 30 meters. So they've given us the circumference here. The circumference is 30 meters. She would like to use some edging to divide the garden down the center. What length of edging does she need? So to divide it down the center, and they've drawn a picture for us here, is the diameter. She needs to know the diameter. Well, the formula for circumference is diameter times pi. They told us the circumference is 30, so in place of the c, we substitute 30. We will Then to solve for d, to isolate the d, we need to divide both sides by pi. So really we're going to say 30 divided by 3.14 gives us an approximate 9.6. And what unit of measure were we using? Meters. So about 9.6 meters is how much edging she will need. I would like for you all to try the next 3 problems on your own, and we'll check those in class tomorrow. Then our next page is talking about the area of a circle. And to find the area, which is all the shaded region in our model here, to find the area we have to know the radius. And the area is pi r squared, and there's an old joke. Circles are round, but pi are square. Well, that's because the Greek letter pi, which is about 3.14, is going to be multiplied times our radius after we square the radius. So the only number being squared here is the radius of the circle. So to find the area of our first example, area equals 3.14 approximately times 4 squared. So I'm actually in my calculator going to punch 3.14 times 16, which is 4 squared. So about 50.24, and it says to the nearest tenth. I always need to read all of my instructions. So it's about 50.2. And our unit of measure here was feet, and by the way, it's area. So we had feet squared. 4 feet times 4 feet gives us feet squared. And area will always be the unit of measure squared. Now, for example, B, they're trying to trick us. Our formula is pi r squared. I don't have the radius. I have instead the whole diameter. Well, if the diameter is 30, you'll take your diameter and divide it by 2 to find the radius. So what is 30 divided by 2? It's going to be 15. So we know each radius here is 15. So to find our area, it's going to be approximately 3.14, and this is inches, by the way, 15 inches squared, the whole thing, 15 inches squared. So on my calculator, I'm going to use the square button, and I get 225. And I'll take that and say times 3.14. So 3.14 times 225, inches got squared also, gives me approximately 706.5 inches squared. All right, you try the next 2 on your own and then flip the paper over to resume the video. I like to refer to this next type of problem as pizza problems. I don't want to find the area of the whole pizza. I just want to know the area of the piece of pizza that I'm going to be eating. Maybe I'm on a diet. I need to know what area my piece of pizza is. So it actually has a formal name of a sector. The area of a sector, a section. I'm looking for a section of the whole circle. The area of a sector of a circle depends on the radius of the circle. Is it a large pizza or a small pizza? Maybe it's a personal pan pizza. All right, so we need to know the radius of the circle. And then we need to know the measure of the central angle. The central angle this arrow is pointing to is the angle made right here with these 2 radii. By the way, this is a radius and this is a radius. So 2 radii are cutting my piece of pizza. And this angle is my central angle. So I need to know the measure of my central angle, which is the angle with the vertex at the center. That's where it gets its name, central angle. It's coming off the center of the circle. And then I'll be able to find the area of my sector. All right, here it is in words. The area of a sector is N, where N stands for your central angle. N is the degree measure of the central angle of the circle. And R stands for the radius, so it's N over 360 pi r squared. So in other words, what fraction of the circle are you looking for? To find the fraction of the circle, it's how many degrees. We talked about this when we made our pie chart, so this really should be reviewed. So for our first example, I'm given n is 36 degrees. My radius is 6 inches. So to find the area of the shaded region to the nearest tenth, I'm going to simply plug it into n over 360 pi r squared, because pi r squared would be the whole circle, but I only want a fraction of it. So this is the area I am looking for. So n, we said, was 36 out of 360. Pi times my r is 6 inches squared. So that gives me 1/10, because 36 goes once and 36 goes into 360 10 times. So 1/10 of 3.14 times, and 6 squared is 36. And I know that my final answer is going to be inches squared. So 3.14 times 36. So I'm going to be taking a tenth of 113.04. I'm going to go ahead and leave it 0.04 and only round at the end. And so when I divide that by 10, I get my answer. And again, it's going to be an approximation because we used 3.14 instead of pi. It's approximately 11 point to the nearest tenth. That'll be 3 inches squared. That's the area of my sector, that piece of pizza. I'd like for you to try example 1 and example 2, and I'll do the word problem with you. The radius of a circle is 5 feet. It has a sector with a central angle of 54 degrees. So let's draw a circle. Mine's a little bit lopsided, but that's okay. So our central angle here is 54 degrees, and it told me the radius is 5 feet. Notice if they don't provide a picture, I can always draw my own picture. And it wants to know what is the area of the sector to the nearest tenth. So they're asking us for the area here of this piece of pizza. So the formula is 54 out of 360 pi r squared. And you can not write the feet, just know that in the end you better have feet squared as your final answer. And the more you practice this, the better you're going to get at using your calculator to say 5 squared is 25 times 3.14 times 54 equals divided by 360, and all of that done on my calculator gives me approximately 11 point, and does it say to the nearest tenth? It does, to the nearest tenth, 0.8 feet squared. When using your calculator, the main thing to remember, this is understood over 1, so the whole multiplication, the numerator acts as a grouping symbol. Okay, I don't know what happened there, but I lost it. I had to rewrite it. So the numerator here is a grouping symbol. So you do all of the multiplication on the top. Take care of your parentheses first. So square your it was 5. Square your 5. When I wrote it back wrong. Square your 5, and then multiply it times pi, and then multiply it times 54. So take care of your numerator, then divide by 360. That's how you'll do that quickly on your calculator. And in our last few minutes together, I want to talk about composite figures. We've talked about triangles, trapezoids, parallelograms, and circles. So what happens when we compile the two together? To find the area of a composite figure, you have to decompose the composite figure into figures with areas that you know how to find. Then you'll use those formulas and put those back together. So let's just do example A and B together before we are out of time. So in example A, I have a trapezoid and a triangle. I highlighted the trapezoid in yellow and the triangle in blue. So here's my plan. I'm going to add the trapezoid to the triangle to find the total area of my composite shape. So I wrote each formula, and then if you look at all the information you're given, the 5 and the 7 gives me the second base of 12. So it's the height, which they tell us here is 7.5, times our two bases, and then the triangle is base times height divided by 2. So in the end, So as we do the math and we take half of the product of the height times the bases and half the base times height, you end up with 108.75. And remember, this is meters, and remember, this is area, so it's meters squared. I want you to try B without me. I've set it up here. We have half of a circle and we have a